We're given a right-angled triangle and asked to find values of a, b and c so that they are all rational numbers. Consider a right-angled triangle. We should actually know that 3, 4, 5 is a right-angled triangle. Using Pythagoras' theorem, a squared is b squared plus c squared. We know that 5 squared is equal to 4 squared plus 3 squared. 5 squared is 25, and that's equal to 16 plus 9. So 3, 4 and 5 work. We have a is equal to 5, b is equal to 4, and c is equal to 3. We now want to find values of a, b and c so that b and c are rational numbers and a is irrational. Let's draw a right-angled triangle and start making some choices. We could choose 2 and 5 and then work out the value of a. A squared is equal to 2 squared plus 5 squared. So a squared is equal to 4 plus 25. So a squared is equal to 29, which means that a is the square root of 29. 29 is not a square number, so the square root of 29 is a surd, which we know is an irrational number. So we have a is equal to root 29, which is irrational, b is equal to 5, and all whole numbers are rational, and c is equal to 2. Now we want to find values of a, b and c so that b and c are irrational and a is rational. If we consider Pythagoras' theorem, a squared is equal to b squared plus c squared, we want it so that a squared is a square number. If a squared is a square number, when we square root, we get a whole number. But we need b and c to be irrational numbers. Let's choose b to be the square root of 13. So we have root 13 squared, and choose c to be root 3, so we have root 3 squared. Then a squared is going to be 13 plus 3, which is 16. So a squared is a square number, and a is equal to 4. So a is equal to 4, whole numbers are rational. B was equal to root 13, which is irrational. And c was equal to root 3, which is also irrational.